Okay, welcome to grade 10 math. We are going to do chapter 4, lesson 4, converting equations from standard form. So today's learning goal, by the end of this lesson, I will be able to rearrange an equation in standard form to the slope y-intercept form. So first of all, I want you to try to do some rearranging here. Let's say we have this first equation and we want to solve for a instead. So why don't you pause the video and try this on your own. See if you can isolate. All right, if you're back now, we can try to do this. So what is happening to the a? What are the operations that are happening to this variable? So first thing it's being done is it's being divided by 2. The second thing it's being done is being subtracted by d. So the inverse of that would be to add d and multiply by 2. Where did I say 2? B. B. Okay, so let's do that. So the first step would be to add d to both sides. So what will that look like after we do that? So a over b, these are going to cancel, and we have c plus d. Then the next step is to multiply both sides by b. Okay, so this will look like these will cancel. You'll have a equals b times c, b times d. We use our distributive property there, right? Good. And that's it. We isolated a. All right, on to the lesson now. So standard form is a bit different. We are used to seeing slope y-intercept form where we have a variable equals a rate times a variable plus a constant. And here, sometimes we find a 3-term equation in this format. So where a, b, and c are whole numbers, not fractions, and a is a positive. So go over that again. These have to be whole numbers, so there should be no fractions. And a must be positive, so the one in front has to be positive. So write each of these equations in slope y-intercept form, then state the slope and the intercept. So if you notice, what's the advantage of doing all this? The whole purpose is we can't tell what the slope is. It's not always the number right in front of the x. Sometimes after you rearrange it, you realize that's not what the slope is. Also, the y-intercept, you think, oh, that must be the y-intercept. Again, once you rearrange things, things can change a little bit. So let's see, we need to get y all by itself. So this is standard form, and this is, now we need to isolate. So one quick way to do this is if we're giving it a negative y, I'm going to move that one over, because then it's going to turn to positive. So on my next step, I have y equals, and it's positive, and I have x minus plus 3. And I didn't have to move anything else around, so the signs didn't change. Just this one. And that is the same as writing it. Like I can reverse these now. I have y equals x plus 3. Nothing had to change there, because the equal sign's like a mirror. We just sort of mirrored it. So what would be the slope? In this case, it was fairly easy and straightforward. So here's the slope equals 1. Here's my y-intercept, which we call a b, equals 3. We remember this from earlier. Okay, our last unit. Okay, this is going to look at it a little differently. So we want to get the y by itself. It's already positive, so there's no sense in moving it. I'm going to move this over, okay, and we have 3y, didn't go anywhere. It didn't go anywhere, equals. Well, this one came over here, so it's negative 3x. Okay, we want to bring the x away from the y. Brought the negative 6 over, turns to positive 6. All right, the only thing left to get this y all by itself is to divide by 3. So what we do to the left side, we must do to each term on the right side. So these cancel, y equals, and now we have something happening here. 3 goes into 3 once, and it's negative, and 3 goes into 6 twice. All right, so we can take information from this. The slope is -1, and the b is 2. So we see that it's useful to turn our formula into y equals mx plus b because it tells us the slope and the y-intercept. All right, here we go again. So let's say we didn't move that. Like we just really like working with the y on the left side. So we might want to bring the x over, bring the y over, and let's see what we have. Well, we're left with a -1y equals, bring that over, and we have negative x. So the positive x became a negative x. -1 becomes a positive 1. Of course, we don't want to leave it with -1y. So just like any coefficient, we divide that out. And what you do to the left, you must do to the right. So those are going to cancel. We have y equals. These make a positive 1, because it's 1 over 1. There's a 1 here. 1 over 1, x, and then a positive and negative is negative, and 1 over 1 is 1. So slope is 1, y-intercept is -1. Very good. How can we relate this to a graph? Okay, now we're going to try number 2. Number 2 says, make a table of values and graph the equation. So one thing we never know exactly how much we're using on the left side versus the right side. So I know we used to do 1, 2, 3, 4. That was useful, but when we really don't know, sometimes I like to start with 0 in the middle and then go a couple points this way and a couple points this way. So how are we going to figure that out? So to make a table of values, so we have to substitute x into these values. So if I go 2, let's do the first one here. X, we'll say that x, what about when x equals -2? So when x equals -2, 2 times -2 minus y plus 4 equals 0. We got to solve this. So -4 minus y plus 4 equals 0. Okay, I want to get y by itself, so I'm going to bring this over. I get -4 plus 4, I get 0. Well, on this side, I got y. So what did we get? Y equals 0 at -2. Now try, what about when x equals -1? So 2 times -1 minus y plus 4 equals 0. So we didn't need that there. All right, keep going. So -2 minus y plus 4 equals y. I think we want to do the same thing again. Bring the y over here. So we had 0 there before. And so we have -2. -2 plus 2 is +2 equals y. Put that in there. +2. Okay. Back to a different color here. What about when x is 0? 2 times 0 minus y plus 4 equals 0. Well, again, bring your y over, and you just keep substituting. This is going to be 0 plus 4 equals y. Y equals 4. And then we can put that in. So we get the point here. We're going to keep going. You can go a couple more times. All right, what about when x is equal to 1. Well, 2 times 1 minus y plus 4 equals 0. Bring this over. We have y equals 2 plus 4 is 6. So we have 6 here. One last time. If x was equal to 2, okay, 2 times 2 minus y plus 4 equals 0. We're going to have y over here. Bring the y over. We have 4 plus 4 is 8. So we have 8. So we have these points now. So now we plot the points. All right. So let's start at our negative 2. So negative 2, 0. Okay, then now our negative 1, 2. Negative 1, 2. And 0, 4. 0, 4, of course, that's our y-intercept. This is our y-intercept. Okay, so we got a hint there. All right, now we can't really go 1 and 6. Well, that's way up here somewhere. And then 2 and 8 is way up here. So sometimes that happens. We fall off the graph. Okay, and it says graph the equation. So I already have this line already ready, but you'd probably want to have a ruler ready to do this work for you. Okay, and make a nice straight line. Good. And now it said identify the slope and the y-intercept. So a couple ways you can do this, right? I think we already knew the y-intercept. The y-intercept is right here. So the y-intercept. So b is 4, which means 0, 4. Okay, so y-intercept, b equals 4. Now how do we find out our slope? Well, we could use the rate over here. We could go, okay, it's going up by 2's and over by 1. Or we could do this type of thing where we count. Okay, a rise of 2, a run of 1. So slope is 2 over 1. So slope is 2. We don't have to say over 1 because I think over 1 is just the numerator. So can you rewrite this into an equation? So instead of isolating it like we did, we used, a table. We used a graph in order to come up with our slope and our y-intercept. And we can do that then. So y equals mx plus b. So what would that be as an equation? Y equals 2x plus 4. So again, you might find that in our first question, it was easier to just isolate by moving things around, but you can see that you can get this information from a graph or a table as well. All right, very good. Now, if you haven't tried these questions before I'm taking them, you might want to pause the video and try it out. Sometimes we have a standard formula. You don't have all the information you want, but you have some information on the variables. So here it passes through. That means somewhere in the graph, it passes through this point. So we know that these two x and y values lie on this line. So we have 3 variables, 1, 2, 3 unknowns. And so when we can put a couple known values into the unknowns, we can solve for the third one. So we are looking for C. So let's substitute. So substitute x equals 2, y equals 4, and C is what we're looking for. So 6 bracket plus 8 bracket plus C equals 0. So if I want to put those numbers in, 2 and 4, I can solve. So 6 times 2 is 12, plus 32, plus C equals 0. So let's keep combining here. So we're going to have 44 plus C equals 0. Of course, we want to get C all by itself. So we're going to bring 44 over. And so we have C. Oh, that was not a good idea to make that a positive. Make sure you're catching yourself when you make those mistakes. We have negative 44. So C equals negative 44 in order to make this correct. All right, very good. So the next one, the movie theater charges $5 for children and $10 for adults for one movie. Write an equation to represent the total ticket sales as T. A T represents the total ticket sales in the dollars, and C represents the number of children tickets sold, and A represents the number of adult tickets sold. So this is where we don't have, I like to use traditional y equals mx plus b formulas. They don't work for these ones. So this is where standard formulas work much better. So if we say that T is the total, okay, so we want to kind of find out that. That's the main thing we're looking for. And we want C to represent the number of children's tickets, and we want A to represent the number of adult tickets. So there's our three unknowns, our three variables. Now, is there a rate given to children tickets? Yes. This is a rate. This is another rate. Well, the rate is for every ticket. So $5 for every ticket. So $5 for every ticket, and they add. It's not like you're subtracting. You're saying 5 children's tickets, or $5 per children's tickets, and $10 per adult tickets will give us a total. And I think that's pretty much all we do. There's no other question to ask. So it's just saying, come up with an equation. So therefore, that's our equation. T equals 5 times C plus $10 times A. Number of children, number of adults. So if we had some information like, oh, 3 children and 7 adults showed up, we could find out a total by substituting those in. So that's the usefulness of standard form. You know, you might be asking yourself, why is standard form useful? It wasn't helpful for slope and it wasn't helpful for y-intercept, but this is where it comes into play when we have double dependent problems. All right, let's move on to our next set of questions. Well, this is exactly the case. So now when we have our equation, we can start substituting. So let's take our equation from before. T equals 5C plus 10A. And we're going to substitute C equals 40 and A equals 60. Very good. Okay, so now we can get a total cost because now we actually know some numbers. Now remember, it's $5. There is dollars here, times 40 plus $10 times 60 adults. That's strange. I don't know how many times you'll see 40 kids and 60 adults. Okay, so then we want to make sure we have our calculator out. Maybe if you need it. 5 times 40 is 200, plus 10 times 60 is 600. T equals 800. Therefore, total ticket sales is 800. Good. Now, of course, we always want to know sometimes a missing variable for, how many people attended and so on and so forth. So here, it's kind of rearranging your equations to isolate C because they want to know how many children tickets. So we could just put it in like that, but then we have to rearrange afterwards. What if we rearranged first? So the total ticket sales are T equals 2,500 the number of children are what we're looking for, and our number of adults is 150. So we still know 2 out of the 3 variables, and we're solving for the unknown one. So, but because it asked, we better do what we're asked. So let's go t equals 5c plus 10a. We want to isolate for this. Okay, so what can we do? Well, if I want this all by itself, I'm going to bring this over. That's the first thing I'll do. And so I have t minus 10a. Okay, so that's where the 10a came. T was already waiting. And 5c. And now we don't want the 5 times the c anymore. So we divide everything by 5. And we can do it that way. So we'll have 1 over 5 times t. Now 5 into 10 goes 2 times. Times 10a, 2a, and c. So that's our answer there. So now that we've isolated it, we can put our numbers in. Okay, so let's do that. Substitute. And for a, substitute 150. Okay, so let's take this equation. C equals 1/5 t minus 2a. C equals 1/5 of our big number we had here, 2,500, minus 2 times 150. Okay, well, this is just division. So 2,500 divided by 5 is, of course, 500, minus 300. And we find out that we had 200 children attending. So therefore, 200 children had tickets or attended, whatever you want to write. Okay, we come to the next question, where we have to now isolate the A. Find the number of adult tickets. So that's really what we're looking for. Okay, and then we have the total sales. T equals 3,500. And then we have child sale tickets were sold. The number of child, that's not money, but it's how many tickets were sold. So let's start off with our equation again. T equals 5c plus 10a. We want to isolate that a. So we need to isolate the a. So we're going to move this over. And now we have t minus 5c equals 10a. Of course, we can't leave it like that. We need to get rid of the 10. What we do to one side, we must do to everything on the other side. And I would do that individually. All right, so we finally have an equation. A equals t over 10 minus, now can we reduce this? Think about that. 5 over 10 would really be the equivalent of 1 over 2 times c. Okay, so t over 10 minus 1/2 c equals a. You know, this sounds like a strange equation, but we can use this, all right? So a equals, let's just write it out one more time, nice and neat. We could even say 1 over 10 t minus 1/2 c. We are going to substitute t equals 3,500 and c equals 250. All right, let's solve that then. 1 over 10 t minus 1/2 c. So what goes into there? So 3,500 in for T, 250 in for C. And so when we see this information, really it's just going to say 1 times that divided by that. So what is 3,500 divided by 10 is pretty easy. That's going to be 350. And what is 1/2 of 250? That's really what we're saying. 1/2 times that is going to be 125. Okay, and finally, how many tickets for adults? Well, punch that in and we get 225 tickets for adults. I guess you could put that into a therefore statement. Okay, very good. So good lesson. That's an important way to learn how you can use y-intercept and the slope, the the y equals mx plus b, or we call that the slope-intercept form, how we can change that into standard form, or we can start with standard form and change that into y-intercept form. Very important because y-intercept form has the advantages of giving us the slope and the intercept. We can use tables to interpret the formula, and we can use graphs to interpret the formula. With that, we can also turn those back into those variables that we need. So thank you for listening, and I hope this helps you. We'll see you next time.